Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. I step out inside, and here we are going to be solving radical equations. Now, this means that we have radical expressions of some sort on opposite sides of the equation. There could be one, there could be two, there could be three. I don't think I have three in any of these things here. And I'm going to show you the tips and tricks of doing this. It has a little bit to do with how you'd solve quadratic equations that are in a factored form a little bit, and just kind of doing the inverse. A couple little things here and there that's going to have to happen when we do, or what they look like. There it is. All right, so let's jump straight into it right now. 10 questions. And I think they cover every kind of problem that I want to do. I think 10 is the longest. It has stuff like that. Solve each equation. Remember to check for extraneous solutions. So these things will exist here. Extraneous solutions, meaning solutions that don't properly work sometimes in a problem. And we're going to have some. And we'll kind of maybe see why that'll happen. Not in a graph form, but just in the equation form, at least for one of them, and then just by it. Okay, so 2 equals the square root of x minus 8. Now, if I want to solve for x, I'm going to have to get it outside of its square root. And, you know, one of the big things you're going to have to do in these problems, this is already taken care of, but you want to isolate the radical. You want to get this square root thing by itself on its own side of the equation. The benefit is when you square both sides of this equation, this is treated as a single quantity, and it's not added with anything like a plus 7 here, where squaring it doesn't really get rid of the radical in the same way that it does here. And I'll show you one of these at some point. But if I square both sides right here, 2 squared is 4. The square root of x minus 8, quantity squared is just x minus 8. Add 8 to both sides, you get x equals 12. Now I will double check and everything here. I believe I haven't done these in at least a year, so I got to remember the conditions for which it would make extraneous solutions or not. This, I know personally off the top of my head that I'm not going to get an extraneous solution here, and I know why for different reasons, but you can double check that. Does 2 equal the square root of 12 minus 8? 2 equals square root of 4. 2 equals 2. That seems to check out right there. It's not extraneous. That is the solution. Now, number 2 right here, the square root of 15 minus x plus 7 equals 4. You do not square both sides right now, because here's the problem. This squared right here does not become 15 minus x plus 49. You don't just square this quantity and then square that guy right there. You would have to FOIL. And FOILing means root 15 minus x would have to multiply by 7 twice and then add together. And then you would have still a radical in there. So no, it doesn't become that. I can't square it just yet, at least not in that appearance. I am going to have to start by subtracting 7 from both sides like that, just to get things cooking. So now I have the square root of 15 minus x equals negative 3. Now I can square both sides because my radical is isolated. And like I said, this is something that you would do if you had a perfect square. If I had a perfect square quantity like this, like x minus 5 squared equals 3, you know, now I can take the square root of both sides because I have that isolated thing. Anyway, so that's just a part of it. But I square both sides here, and I'll get 15 minus x equals 9. Let's subtract 15. Negative 6, so x equals 6. Now, when you double check this one, always do it with the original, but take a look at what happens here, and I will show you based on this one, what's going to happen. So the square root of 15 minus 6, and I'm not going to write this over each time here. That's the square root of 9, and the square root of 9 is 3. And that's 10 equals 4. Ooh, see, something went wrong there. Therefore, this is an extraneous solution. So x does not equal 6. This actually ends up being no solution. Now, what happened here? Well, what happened here is, you know, consider this. If this was a negative 3, that would have been fine. Negative 3 plus 7 is 4. Because notice here, the square root of 15 minus x equaled negative 3, not positive 3. But when I squared the negative 3, it still became a positive 9. So the problem is, once you square these sides of these equations here, you are not only changing the nature of this from a radical equation function to a linear function right here, but this constant now that had a negative in it has now turned positive. You've changed it. It didn't know whether it was negative or positive before. So what could have intersected here, what could intersect here and y equals this and y equals that cannot intersect here. These two graphs never intersect with each other here. This is a square root graph that does something like this over here, and then this is a square root graph that does, or this is a linear graph that does something like that right there, and they just don't intersect. They just don't intersect together. I guess it would be down further. But anyway, there's that. Okay, number 3, we have two radicals this time, but because they're on their opposite sides, they are on their own sides of the equation, they're isolated. So I can square both sides right now and be good to go. I will get negative 6 minus x over here. I'll get negative 15 minus 2x here. And then you solve the rest of the way. If I add 2x and add 16, I get negative 9. And I'm done with the problem. I can double check, and I'm going to. I get negative 16 minus negative 9 is negative 6 plus 9, which is 3. So square root of 3 right there. And then here I get negative 15 minus 2 times negative 9, negative 15 plus 18 is square root of 3 right there. Root 3 equals root 3. That checks out. All right, same thing on this problem here. Let's go ahead and square both sides. And here we're going to get 1 minus x equals x plus 5. Now, if I add x over here, I get 2x equals, and here I get negative 4. So x is negative 2. Let's double check that. Sometimes I don't even trust my own work. 1 plus 3, again, that's root 3. Negative 2 plus 5, that's 3. So root 3, again, that seems to also check out. Okay, so you can see how this can sometimes go faster. Now, number 5, once again, now I have an x minus x outside of the radical here, but once again, I do need to isolate my radical itself right there before I square both sides. So I'm going to add that x over. I'm going to square both sides right here. And this time I get 30 minus x equals x squared. Okay, well this is a quadratic equation. Let's add the x and subtract the 30 over here. And then let's solve this thing by factoring. That's x plus 6 times x minus 5. So when you solve that there, you get x equals negative 6 and x equals positive 5. Now let's double check for extraneous solutions here. This can happen a lot, especially when there's an x on the outside of it, because there's no knowing whether that x being positive or negative really changes things. Let's see what happens if x was 6 here, negative 6 here. That would be the square root of 30 plus 6 minus negative 6. Plus 6 right there equals 0. See, that doesn't work. 36 plus 6, square root of 36 plus 6. 12 don't equal 0. So negative 6 does not work. That is extraneous right there. And you can tell, once again, if this somehow turned into negative 6 plus, you know what I mean? So it's like it wants to do the right thing, but squaring it changed the nature of what we did with it, right? That's kind of the idea. Let's try it for x equals 5. Right here, that's square root of 30 minus 5 equals 0. So square root of 25 minus 5 equals 0, and 5 minus 5 equals 0, 0 equals 0. That does check out. So you can see that 5 does work, but negative 6 does not. It does what it wanted to, right? It was a solution to this portion right here, and it wanted to be with a negative 6, but it didn't quite pan out. All right, this one, the radical's isolated right here, but on the other side, it's a binomial that will be squared. So right here, we'll have 8x plus 8, but on the other side there, we got to do x plus 1 quantity squared. That's actually x squared plus 2x plus 1. Remember, you expand that through foiling, or you know your binomial expansion of that, a squared plus 2ab plus b squared. All right, let's do the same thing, though. Let's subtract the 8x over, you get negative 6x. Subtract that 8 over, you get negative 7. And let's once again factor x minus 7 times x plus 1 equals 0. So x equals 7, x equals negative 1. All right, let's try those and see if they work. I'll do this mentally here. 56 plus 8 is 64. Square root of 64 is 8. 7 plus 1 is 8. 8 equals 8. 7 checks out. Negative 8 plus 8 is 0. Square root of 0 is 0. Negative 1 plus 1 is 0. Negative 1 checks out. Both do work. So 2 solutions to that one right there. 2 solutions. All right, let's keep moving forward. I got 4 more problems, like I said, or I don't know if I said it, but I'm only 9 minutes in. This is one of my fastest videos ever. Pretty quick. Let's once again square both sides right here. But, you know, this will be relatively quick with this stuff here. Squaring this side will give you x squared minus 16x plus 64. And this side you'll get 52 minus 8x. Let's move these things over here. Add 8x to both sides. You get minus 8x. Minus 52 is plus 12. Let's write that correctly. Set it equal to 0. So that's x minus 6 times x minus 2 equals 0. So x equals 6 or x equals 2. Now, is that true? Well, both of them might be problems here. Take a look at this one. Let's Let's even ignore the right side for a second. I'll rewrite it, but let's ignore the right side for a second when we even look at this thing. Except the fact that it's a square root. 6 minus 8. 6 minus 8 is negative 2. Negative 2 equals square root of something. When was the last time you took the square root of a number and got a negative answer out? You can't get that, right? That's what I mentioned on this other problem right here. So take the square root of something and get negative 3. That's not going to happen. This is always going to be a positive number right here, and we squared a negative to turn it positive. That's what gives solutions. Same thing right here. Negative 2 equals, I don't care what this is. It's probably going to be positive 2 on this side. 52 minus 48 is 4, and negative 2 equals 2. Nope, that doesn't work. That one is extraneous. I always do that whenever I spell extraneous. I always put a T instead of the X. And then right here, you try 2. Same thing. 2 minus 8 is negative 6. Negative 6 equals square root of 52 minus 16, 36. Negative 6 equals 6. I don't think so. That also is extraneous. Both solutions are extraneous. Therefore, there is no solution to this thing as well. So again, you must double check. I'm not just trying to see if I got it right. I'm legit trying to see if I'm getting extraneous solution sets here. The only time, I got to make sure I say this right. The only time that you wouldn't have to check for an extraneous solution is a problem like number 1. You have only a single square root, no x's outside of the square root, and the other side of the equation is a positive or 0 constant. You also technically shouldn't have to check if you have a negative constant like that, and this one's not negative, because they won't intersect. That'll always be no solution, I guess. But well, I'm still going to check them for you. All right, this guy right here, once again, let's isolate the square root. Square root of 3x minus 17 equals, and let's add x over. Let's make it say x minus 5, and square both sides there. Squared, squared, and here we're going to get 3x minus 17 equals, this is x squared minus 10x plus 25. So kind of same old, same old. Subtract 3x over, add 17 over. That'll be x squared minus 13x plus 42 equals 0. 7 and 6, x minus 7 times x minus 6 equals 0. So x equals 7, x equals 6. Let's check them. 7. Negative 7 plus 20, square root of 21 minus 7. Negative 7 plus square root of 4. Negative 7 plus 2. That's negative 5. 7 checks out. 6. Negative 6 plus 18 minus 17 is 1. Negative 6 plus square root of 1 is 1. Negative 6 plus 1 is negative 5. That also checks out. Both solutions work there. All right, 2 more problems. Here we go. Squaring both sides. Squaring both sides there. We're going to get x squared minus 4x plus 4 equals 5x plus 40. Let's subtract the 5x. Sorry about that, if you heard that. 36 equals 0. Did I do that right? Yes, I did. I just don't know if does that. Yeah, that factors. Never mind. That's x minus 12 times x plus 3 equals 0. So x equals 12, or x equals negative 3. Now, I'm already seeing the negative 3, and I'm thinking that's going to be a problem. Negative 3 minus 2 is negative 5. The square root of something being negative, I don't think it's going to work. That'll get you negative 5 equals 5, and that doesn't work. This one's going to be extraneous right there. I imagine 12 will work. Let's take a look. 12 minus 2 is 10. Square root of 60 plus 40 is square root of 100. That's 10. That one does check out, so that's good. X equals 12. And finally, number 10. Now, here's the problem with number 10. No matter what I do, when I square both sides, I'm still going to end up with a radical somehow. Okay? Some way, somehow. But what we want to do is alleviate the number of radicals that we have. So you still isolate one of the radicals. I'm going to go ahead and add root 3x minus 2 over. My goal is to eliminate one radical at a time, but it comes at still a cost. There's nothing I can do when this happens. See, here's what happens when I end up squaring both sides here. The left side is good. That's 5x minus 5. The right side is not good. This is a squared plus 2ab. 1 times root 3x minus 2 is root 3x minus 2. So, boom. Plus b squared. So you can see I didn't ever get rid of the radical. That's why squaring a side that has a quantity with the radical and any other term is still going to leave you with the radical. But I did get one of them, and I can start to work this down. Let's subtract the 1 over. Oh, let's do this actually. Let's combine like terms over there. 1 minus 2, so 2 root 3x minus 2 plus 3x minus 1. All right, let's add the 1 over. Let's subtract the 3x over. Now, you have some options in what you can do here. Let me move that a little closer. Like, you know, I'm going to square both sides, and I'll do that at some point. But let's isolate that radical. Let's divide everything by 2. Just make it a little bit smaller, help ourselves out right there. That's going to be very helpful for us. Even if this couldn't divide evenly, I think generally you'd want to do that. That's what I would do with a quadratic. So let's just do it here. So that'll be x minus 2. X minus 2 equals square root of 3x minus 2. Now let's square both sides again, right? Now we're kind of at that stage where it'll work ourselves out. So you can see why that's a little bit more of a doozy. X squared minus 4x plus 4. We just saw that in the previous problem, I think. And 3x minus 2. Subtract 3x here. Add 2. Whoops, that's minus 6. And x equals 6 and x equals 1. Now let's check those, and we got to check on the original here. So let's try 6. 30 minus 5 is 25. Square root of that is 5. 18 minus 2 is 16. Square root of that is 4. 5 minus 4 is 1. 6 works. What was the other one? 1. 5 minus 5 is 0. Square root of that is 0. 3 minus 2 is 1. Square root of that is 1. 0 minus 1 is negative 1. Negative 1 does not equal 1. So 1 does not work. Again, you can kind of see its origins and what it wants to do and what's happening there. So just x equals 6 is the only one that works there. And that's it. That's what solving radical equations is all about there. Of course, there could be even trickier problems than that, just with regard to what's going on. But those are the basic ideas of it, that you isolate the radicals, whatever it is, you isolate them, you square both sides, and then you solve. Sometimes you got to solve a quadratic, sometimes it's linear, and sometimes there are extraneous solutions. If all are extraneous, there's no solution. Otherwise, both solutions do work. So that ought to do it for this one, guys. This was a nice short one. This is Mr. Robinson checking out and saying thank you for watching this, and I will see you in the next one.